Hello everybody, welcome into another lesson. So today we are going to talk about properties of parallel lines. Well, there's a postulate and three theorems you need to learn today that you're going to use pretty much from here on out for the rest of geometry, okay? And you might even apply it a little bit higher. Now, if you remember nothing else from this course, remember the theorems and the postulate you're going to learn today, in addition to vertical angles are congruent, and then the angle bisector theorem, the midpoint theorem, and all those, and the angle addition postulate, the segment addition postulate, the real basic ones. These are all very important and will help you. We have our first postulate here. It says that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So yesterday we talked about parallel lines being lines that never intersect. We also so we have the parallel lines here, A and B, and you see that red arrow in the middle of the line, just the one red arrow? Whenever you see that in the middle of the line, on both lines, that means both lines are parallel. So that's how you'll be able to look at a diagram and see if lines are parallel. If you don't see that arrow, you have no way to know if they're parallel or not unless either A, your textbook exercise tells you the lines are parallel, B, your teacher tells you they're parallel, or C, you see those arrows, okay? We have a transversal line here, C, that cuts through lines A and B. Well, these two parallel lines being cut by a transversal, the corresponding angles are congruent. We talked about corresponding angles yesterday also. And if we look at this here, the corresponding angles, we have 1 and 2. Well, let's start out by stating A is parallel to B. A is parallel to B, that was clearly given to us, so 1 and 2 are corresponding angles, therefore they would be congruent. So angle 1 is congruent to angle 2. What other corresponding angles do we have? 5 and 6, they're in the same position on each of the two lines, so angle 5 would also be congruent to angle 6. What other ones do we got? Angle 3 and angle 4, they're in the same position on each of the lines, they're corresponding, so angle 3 is congruent to angle 4. What else? Then we have angles 7 and 8. Those are corresponding angles. So by this postulate here, we can determine that angles 1 and 2 are congruent since they're corresponding angles, as well as 5 and 6 being congruent to each other, 3 and 4 congruent to each other, and 7 and 8 congruent to each other. So that's a pretty straightforward one there. Now I'm going to keep the diagram up. Well, we're going to keep that A is parallel to B. We're going to have the exact same diagram for our first theorem of the day. Good news is these theorems, I'm not going to make you prove them because they're based off the postulate we just learned, and we could prove them, but I think that's just taking some unnecessary time. The real meat of what I want to get to today has some algebra in it. So then because I really want to see everyone keep up their algebra that they've learned or they're familiar with. That's very important. So the theorem is that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. I abbreviated alt inter like so. You can base this theorem and the next one, and actually the one after that, all off of the original postulate that we just learned. So if you have two parallel lines that are cut by a transversal, so A and B are still parallel, we see those red arrows, they are cut by transversal line C, then alternate interior angles are congruent. So let's look at alternate interior angles. First, let's talk about the interior part. The interior, it's in the middle, it's between the two parallel lines. So angles 7, 5, 2, and 4 are interior angles. Now what about alternate interior angles? So what about, alternate interior? So they're on the inside, only they're on the opposing side of the line and up and down from each other. So angle 5 is an alternate angle to angle 4. It's higher up here on the right side of the transversal, and angle 4 is lower down here on the left side of the transversal. Those would be alternate interior angles. So by this theorem, angle 4 would be congruent to angle 5, and then 7 and 2. Angles 2 and 7 are also congruent to each other by alternate interior angles are congruent. So we got two pairs of alternate interior angles that are congruent to each other. Angles 4 and 5 are congruent to each other, then angles 2 and 7 are congruent to each other. Alright, I have yet another theorem. I'm going to keep the same diagram, but the wording's going to change a little bit. Alright, so if two lines are cut by a transversal, then same side abbreviated S-S interior, same side interior angles are supplementary. So this theorem states that if two parallel lines are cut by a transversal, so again, lines A and B are parallel to each other, we see those arrows, they are cut by transversal line C, then the same side interior angles are supplementary. So again, let's start with interior. Interior, as we said with alternate interior, it's all the angles between the two parallel lines on the inside. But this time we want to talk about same side interior angles. Same side, they're going to be on the same side of the transversal. So angles 2 and 5, for example. Angles 2 and 5 are supplementary. So angle 2 and angle 5 are supplementary. So in other words, if you add up the measure of those two angles, you'll get 180. And then likewise, angles 4 and 7. Angle 4 and angle 7 are also supplementary because they are same side interior angles. So with basic parallel lines and transversals, you have the corresponding angles are congruent, you have alternate interior angles are congruent, and then you have same side interior angles are supplementary. Okay? Now, I have another theorem which is a little bit different. It's just a little bit different, but it's still incredibly useful for what we're about to do today and in the future of geometry, and maybe even in some of your higher up classes that you'll take later on. Alright, so let me draw another diagram here. It's going to be a little bit different this time. Let's do this. Okay. Here we will have line A again. This will be line B. This will be line C. Likewise, like before, A and B will be parallel to each other, but C is perpendicular to A. So we're about to discover an interesting theorem about parallel and perpendicular lines. This theorem states that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay? So, to read this theorem, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So here in the diagram, we have lines A and B. They run parallel to each other. Then we have the transversal line C that cuts through both of them. And we can see here by the right angle marker, that usually denotes perpendicular. That's how you'll tell that little corner. We have line C is perpendicular to line A. Well, by this theorem, not only is it perpendicular to A, it would also end up being perpendicular to B. So we can establish here that A is certainly parallel to B, and then A is perpendicular to C. That was given to us. And then by this theorem, B is also perpendicular to C. So that's basically what this theorem is stating. Alright, it's time to apply the postulate and these three theorems that we've learned today into some problems. And these are probably some of my favorite type of problems, honestly, because they involve algebra. In case you haven't figured it out, I just love algebra. So, alright. What have we got here? I got 11 exercises today. So, first let me write down what the objective is here. Find the values of x and y. So these will be problems we're going to find the values of x and y, okay? So first thing, draw a nice triangle, and then extending from that triangle, this extends a little more, and then this extends. Alright. And then we can use the fact that these two lines here run parallel to each other. So these two lines in the diagram will run parallel to each other. This angle is equal to 60 degrees. This angle is equal to 61 degrees. This angle here is x, this one is y. We got to figure out what are the values of x and y. Well, we know here that we have two parallel lines. This top line is the transversal between these two parallel lines, correct? Okay. Now, again, it looks like x and 60 are going to be alternate interior angles from this diagram because they lie in the interior. They lie in between these two parallel lines, but they're on either side of the transversal. So x, therefore, is going to equal 60 degrees. So we found that by alternate interior angles are congruent. So you see how this is starting to come into practice. And again, we have yet that this line is parallel to this line, only this time this big line here to the right is the transversal, but 61 and y lie in the same position with respect to each line, so they would be corresponding angles. So you could say y is equal to 61 degrees. So by alternate interior angles are congruent, we got x equals 60. By corresponding angles are congruent, we got y equals 61. So that's how these can apply with algebra. Make sure you all could see it well. Okay. Let's go on to the next example here. Alright, another good one. Alright, so let's see here. In this figure, the top line will be parallel to the bottom line. We've ascertained that. You have a right angle here at the bottom. This is equal to 2y. This is equal to 14x. This is equal to 4x. Okay. So we want to again find the values of x and y, don't we? That's the goal. Well, keep in mind here, okay, we have the top and bottom lines are parallel. Let's start with x. This left side is definitely the transversal between the top and bottom lines. What do we know about transversal lines and same side interior angles? They're supplementary, correct? So to find x, what we're going to have to do, since 14x and 4x are supplementary, we're going to add them together and set them equal to 180. So 14x plus 4x would equal 180 degrees, which means then you would get 18x equal to 180 degrees, which simply means that x equals 10 degrees. So therefore x is equal to 10 degrees. Alright, well, let's look at the y side now. Again, you have the top and bottom line are parallel to each other, and the right side's a transversal between them also. We also know for a fact that these are, again, same side interior angles. You have a 2y and a 90. So if we take 2y plus 90 and set it equal to 180, since they're same side interior angles, you would end up getting then 2y equals 90 degrees, which could only mean that y would equal 45 degrees. So therefore, both of these, by same side interior angles being supplementary, we got x equals 10 degrees and we got y equals 45 degrees. Alright, figure out the next problem. Let's see here. Alright, that looks like a doozy. We know here that this line is parallel to this line, and these two lines here are parallel to each other. So you may be wondering why one set has one arrow each line, and then the other set has two arrows each line. That's because you want to separate which lines are parallel to which. If you have multiple sets of parallel lines, you just add an arrow for the next set. So if that makes sense. Okay, what are our angle measures for this one? This one comes in at 120 degrees. This one comes in at x. And then we got here 3y plus 6. So we have parallel lines here with angle measure 120, x, and 3y plus 6. Well, sometimes you can't go right for the variable. Not all the time, unfortunately. Sometimes you need to figure out missing information to be able to solve for the variable. Because all we can ascertain is that x is equal to 3y plus 6 because they're corresponding angles, right? But here's the thing. We want to find the values of x and y. We can't do that if we have two variables equal to each other. It just doesn't work. So here's what we have to do. We know to the left side of this parallel line, this is a 120 degree angle, right? Well, since these two lines are parallel, you have a corresponding angle here. That corresponding angle would also be 120 degrees since corresponding angles are congruent. Now we have a path forward to at least solve for x. If we look at 120 and x, if we put those two angles together, I think it's pretty clear they'll equal 180, right? By the definition of supplementary angles. So let's take x plus 120. We'll set that equal to 180 degrees, which means x equals 60 degrees. So we have now established what x is. It's 60 degrees. Now that we've solved for x, we can now solve for y. Because if x is 60, that means since 3y plus 6 is a corresponding angle to x, 3y plus 6 has to equal 60. So 3y plus 6 would also equal 60 degrees, which means that 3y would equal 54 degrees, which therefore means y equals 18 degrees. So we got x equaling 60 and y equaling 18. And this is why sometimes you can't go right for the value of the variable. You need to fill in missing information. All right. What's the next one? Draw another triangle here. Now what does it do? It extends all the way out here. We're going to extend all the way out here. We're going to extend this down here. And then we're going to cut through here like so. So we have an interesting diagram here. We know that from the diagram, this line is parallel to this line, okay? This here is x, that here is y for those angles. This here is equal to 50 degrees. And then this here is equal to 70 degrees. Okay, so we need to find x, we need to find y. So let's start here. Well, we know here that if we look at these two parallel lines, they are cut by this long line here at the bottom, the transversal. It would appear then that x and 70 are corresponding angles. So therefore, since corresponding angles are congruent, x equals 70 degrees. That's a piece of cake there, since it's corresponding angles. Now here's another thing though. We still have to find y. We still have to find y. Well, let's look at this. If we take x, which is 70, plus this missing angle, plus y, we should add up to 180, right? All three of these angles would equal the line. If you put them together, you add them together. However, that's a missing angle. But easy fix. For this middle angle, we can use the fact that vertical angles are congruent, and this middle angle actually becomes equal to 50 degrees also. So now we have it in such a way that we'll have 70 plus 50 plus y equals 180. So let's do that. So y plus 50 degrees plus 70 equals 180 degrees, right? Which would mean y plus 120 would equal 180 degrees, which could only mean that y would equal 60 degrees. So we came up with x equals 70 degrees, and we came up with y equals 60 degrees. So, yes, that's how you would do that. Sometimes, as I said, you got to fill in missing information. These are kind of like a puzzle in a way, too. If you're good with puzzles, it's not like too hard of one. Largely, if you remember all the theorems and the stuff we've done so far, you'll be just fine. And if you're struggling, always feel free to go back and watch my previous videos. They'll be there forever. There's no shame in that. Alright, let's draw this fine figure here. It's not quite that distorted. Hold on. I want to draw this a little more accurately. Okay. Oh yeah, there is a line intersecting through here. Now, what have we got? We're given that these two lines are parallel to each other. So at least the left and right side are parallel to each other. I think by looking at this, it's clear to see the top and bottom are not parallel. Okay. We have a right angle here, so that means this line's perpendicular to that one. We have 42 degrees here. This angle right here is 3x. This angle right here is going to be 6y minus 6. So we have to solve for x and y. Well, let's start with the 3x. So, we have two parallel lines. Then we have a transversal that intersects those lines, this middle piece, right? The middle piece intersects them. Well, according to this then, 42 and 3x are alternating interior angles. So, we know alternate interior angles are congruent if you have two parallel lines with a transversal intersecting them. So you'll take 3x and set that equal to 42 degrees, which would mean x is equal to 14 degrees. Okay, that was easy enough. Alternating interior angles. Now here's where it gets a little puzzling. So we have 6y minus 6. Now, I know some of you out there are going to say all you need to do is add these up for the sum of the angles of a triangle. Well, I'm saving that for a little bit later on. That is coming, I promise you, but we're not there just yet. We want to do this by our theorems that we've been learning recently and today. So that's the other way we can do it. So anyway, we notice since these two lines are parallel, the transversal here, this transversal to these two lines is perpendicular to the first line. Remember that theorem that said if a transversal is perpendicular to one of two parallel lines, it's perpendicular to the other one also. Yes, so that means right here, this would actually, the whole thing would form a right angle. So now you'll take the value of 3x plus 6y minus 6, set it equal to 90, since it forms a right angle. 3x was 42, so you'll take 6y minus 6 plus 42 and set that equal to 90 degrees. Which means you would get 6y plus 36 equal to 90 degrees, which then means you'll get 6y is equal to 54 degrees, which then means that y is equal to 9 degrees. So we got x equal to 14 degrees and we got y equal to 9 degrees. And I guarantee you, if you stuck these angle measurements in, these would add up to 90. These two angles, you did that, these two would add up to 90. You would have no problem with that. So the perpendicular one finally came up. That one's a little bit tricky sometimes because you can get so used to corresponding angles, alternate interior angles, and same side interior angles but you can end up forgetting about the perpendicular theorem that we talked about. Okay, we have another one here. Let's draw a line. Let's draw a bigger triangle. Here, let's draw a smaller triangle. Okay. So, we have here this line parallel to this line. We have these two lines here parallel to each other. So we have two sets of parallel lines, okay? Now they give us here y for this angle, 55 degrees for this angle. We get x for this angle, and then 50 degrees on this angle. Didn't want to do that. Okay. So here's 50 degrees on this angle here at the right. So we need to find x and y. Well, what we know is that these two lines here, this line and this line, are parallel, are they not? Okay. Well, here's your transversal that cuts them off. That's your transversal that cuts them off. That means 55 and x are therefore corresponding angles because they're on the same side of each of the parallel lines. So, since they're corresponding angles, they're congruent, we got x equals 55 degrees. That one wasn't so bad. Here's where it gets tricky with y. We're not going to use any triangle properties yet. Without using triangle properties, you can still solve this. So, how would we go about that? We don't know what this angle is, not whatsoever. We have no clue what that angle is, because we don't know what that is. But I'm going to show you something here. These two lines, again, are parallel, and this big line here is the transversal that cuts them off. So y and the missing angle here would be corresponding angles. So this angle here would equal y. Well, it looks like we just got further from what we wanted to do. Well, hang on a second. Hang on a second. So, there's something else here. We have this line parallel and this line parallel, and the big top line's your transversal, is it not? This missing angle here and the 50, those would be corresponding angles. So now we know that this angle is 50 degrees by corresponding angles. So we have 50 degrees here, we have y here. Now let's just go ahead and figure out this angle. So again, we have this line parallel to this line, this one here being your transversal. Well, wouldn't this angle here be an alternating interior angle from this one because it'd be in between the two lines? So this missing piece here is 55 degrees. Now, if we take y plus 55 plus 50, won't we get 180 by looking at these three angles? We'll set that up. So y plus 55 plus 50 is equal to 180 degrees, which would give you y plus 105 would equal 180 degrees, which therefore would render y being 75 degrees. So x would be 55, we already got that. Y, by some clever manipulation of the theorems that we've learned, y is 75. So it's about really looking at the whole picture. You don't want to just fixate on one variable. You want to see the whole picture with these. That was definitely a tricky one. Alright, I should have here, I have 3, I have 5 more, and we're done. Now we're going to introduce a third variable in these ones. So we're going to find the values of x, y, and z. So these next 3 exercises, we're going to find the values of x, y, and z. So let's go ahead here. Let me draw this. Okay, this side is parallel to this side, and then these two sides are also parallel to each other. And if you said this is a parallelogram, you'd be correct, but we're not going to talk about parallelograms today. That's for the future, but it will come up in this course, and not too far from now either. So we got the left side parallel to the right side, the top parallel to the bottom. Here's what we're given. Here's y, here's x. This angle is 24 degrees. This angle is 4z. This angle is 56 degrees. All right. So we'll go ahead here now and we will solve for our values. So look at our parallel lines, okay? So we have here this line parallel to this line, right? And we have a transversal that cuts those two lines off, does it not? A transversal that cuts the left side off from the right, goes right through them. If we look at it here, x and 56 would be alternating interior angles. So by alternating interior angles being congruent, x would equal 56 degrees. So we got the value of x. Having found x, let's look at y. Yeah, let's look at y here. So we know this is going to have to be clever because in a parallelogram we have, in lines that are parallel, remember same side interior angles are congruent. Not congruent, I'm sorry, they're supplementary. Same side interior angles are supplementary, are they not? Well, angle y would be supplementary to this whole angle here of x plus 24. Not just x, it's going to be supplemental to the whole of x plus 24. Because the top line's parallel to the bottom line, and then the left side is your transversal between those two. So we're going to have to do a little bit more math here. So y is supplementary. You're going to take y plus, what was your value of x? That was 56 plus the 24. And since they're supplementary, you'll set them equal to 180. Alright, so what we have now is y plus 56 plus 24 equals 180. 56 plus 24, that's going to be 80, so let's see. Y plus 80 equals 180 degrees, which therefore would make y equal to 100 degrees. So in this problem, y is 100 degrees because with these top and bottom lines being parallel, the left side being the transversal, y is supplementary to x plus 24. It's the whole angle, it's not just going to be this part, it's going to be x plus 24 altogether. Then we have the matter of for z. We got to solve for z. Well, couple things. We know 4z is going to be supplementary to 56 plus whatever this angle is, not just 56, because again the bottom line is parallel to the top line, but this time the right side's the transversal. So it's actually going to be equal to the sum of 56 and whatever that angle is. But this goes back to here, we have the top and bottom lines parallel. This time, this diagonal is your transversal. And then 24 and this missing angle would end up therefore being alternate interior angles. So the missing angle is actually 24 degrees. So now 4z is supplementary to 56 plus 24. So let's go ahead and settle that right now. If we take 4z plus 56 plus 24, we set that equal to 180 since they're supplementary. That means we get 4z plus 80 equals 180 degrees, which means 4z equals 100 degrees, which then means that z equals 25 degrees. So it really did come in handy to know about alternate interior angles and same side interior angles. So we got x at 56, y at 100, z at 25. That's what you should get. Okay, what's next? Actually, I'm going to go to 2 more problems. I don't want to drag this out too much longer. There's a reason I'm doing this, though. This time we're going to just find the values of x and y. But these are different problems. We're going to find the values of x and y. Okay. So let me draw my lines here. Okay, this time we have 3 lines that are parallel to each other, because you can have more than one line parallel to each other. We got 3 lines parallel to each other. We got to solve for x and y. This here is 120 degrees. You know, let me make this bigger so I can illustrate a little bit better. I think you need a clearer picture. Hold on a minute. There, that should be clearer. Again, all 3 of these lines are parallel to each other. This angle is going to be equal to 120 degrees. This angle is equal to 2x plus y. This angle here is equal to 2x minus y. And then this angle here is equal to 140. Okay. Here's the thing. We have no way just to solve for one variable at a time, do we? But we know, if nothing else, that when you have two parallel lines, same side interior angles such as these are supplementary. So for the top part, that means that we're going to have 2x plus y plus 120 is equal to 180 degrees. And then for the bottom part, we'll have 2x minus y plus 140 equal to 180, since they're supplementary, aren't they? Well, let's simplify this over here. You would just end up getting, for the first equation, 2x plus y is equal to 60 degrees. And then you have 2x minus y is equal to 40 degrees. Well, what do you know? We have a system of equations. And I told you in algebra, these are going to come up again. We have a nice simple system of equations that, in my opinion, we can solve using the elimination method. So let's add the second equation to the first. If you do that, you'll simply get 4x is equal to 100 degrees, which would mean that x is equal to 25 degrees. So we found the value of x. And then, like in any system of equations, you just put the value of x into one of them. So I'll put it into the first equation. We'll take 2x, we'll do 2x plus y, so 2 times 25 plus y equals 60 degrees, which would mean that y plus 50 equals 60 degrees, which could only mean that y equals 10 degrees. So by using that same side interior angles are supplementary to each other, and then solving a system of equations, we got that x is equal to 25 degrees and that y is equal to 10 degrees. I thought these are rather cool problems. And I got one more like it. Just one more, and then we're done for the day. So now you should be starting to see why Algebra 1 comes before geometry. This is exactly why. We'll even have quadratics in here at times. That just might happen. Okay. Alright, here's this one. We got again that these three lines are parallel to each other. Here's what we got this time. This top angle is equal to 70 degrees. This bottom one is equal to 4x minus 2y. This top one is equal to 4x plus 2y. The bottom one's equal to 50 degrees. So, again, let's start out with our geometry properties. We know we have two parallel lines. Here's the transversal for the first two parallel lines. 4x minus 2y and 70, they're same side interior angles, right? Which means they're supplementary. So we're going to take 4x minus 2y plus 70, you'll set that equal to 180 degrees. Then you take your second angles between parallel lines 2 and 3. They're also supplementary since they're the same side. You would end up getting 4x plus 2y plus 50 equals 180 degrees. So that's what we have so far. Now let's simplify this over here. You'll end up getting 4x minus 2y equals 110 degrees. And then you would end up getting 4x plus 2y is equal to 130 degrees. And then what do you know? We have yet another system of equations. So why don't we go ahead, add the first and the second lines together. you would end up then getting 8x is equal to 240 degrees, which would simply mean that x equals 30 degrees. So we found the value of x, now we just need to find the value of y. Well, let's go ahead here, substitute it into one of these equations. I'll pick the first one again here. So let's do 4x. No, 4x. Not, I don't know what I'm thinking there. No, let's do the second equation because I don't want to deal with a negative. You'll end up having 2y plus 4 times x, so that'd be 4 times 30 equal to 130 degrees, which would mean 2y plus 120 equals 130 degrees, which then means that 2y equals 10 degrees, which then would just give you that y is equal to 5 degrees. So again, by using same side interior angles being supplementary to each other, and then solving a system of equations, we get that x equals 30 degrees, y equals 5 degrees. So that's it for this lesson. I will be out for at least a few days for medical reasons, so there won't be any lessons for a few days. I will post an update about it on my channel here. I hope to be back later this week, at which time we will talk about proving lines parallel. So I hope everyone has a good night. Take care.